This conference will now be recorded.
Hi guys, hope you practiced Docker. Now let's go and let me work with Terraform. So let me share my screen. I hope you can see my screen. So Terraform, actually, we won't be having any specific slides for Terraform because we're going to learn directly from Terraform. Okay. So there is a nice module called Learn. Okay. So which has a lot more modules. So let's go with basic Terraform. This is not necessary. Okay, just hold on a second. Yeah. By the time it actually gets up, I'm gonna get you Terraform module. Yeah. Okay. So if you see, let's go into our vanilla box. So the first and foremost, what is Terraform? See, Terraform is nothing but it's a tool. Okay, it's a tool. It's not a complete tech, but it's an automation tool. It is used for building, changing, and versioning infrastructure safely and efficiently. You might be thinking, what is building? Building is something that so most of the current infrastructures are based on cloud. So when you're in cloud, you have to build the infrastructure. What is basic infrastructure? When you say infrastructure, it means let's say virtual machines. Okay, you have to build first virtual machine. You have to build the virtual routes. Okay, if you are actually working with VPC or virtual private network, VPN, and if your current virtual private cloud is going to communicate with another virtual private cloud, then again you have to maintain the route table. And then yeah, if you are actually utilizing some kind of a cloud native features such as load balancer, so every cloud will provide a load balancer. Okay, so it's their native. So utilizing is a very utilizing them actually has more advantage than utilizing our own. So in Amazon, it would be, for example, Elastic Load Balancer, or in Azure, it would be Load Balancer. So, like cloud native features like monitoring tool setup, which is getting connected with your new instance. How are you actually monitoring it? Alerts, deployment, everything is nothing but building. So, if you are actually deploying an app before, let's say, uh, before 10 years, you manage the systems. That means you maintain the whole servers. Your whole focus is to reduce the amount of time, okay, to correct the system. So if you have a system which is running, let's say Apache web server, and it last year, the current admin didn't update it in a regular manner, okay, and you are in his position. Now it's your responsibility to maintain system up to date. So if you don't update your system, then your system can actually be hacked by somebody. Okay. If you maintain the system, means it should have a proper procedure. That is, the first task would be typically, okay, down the software systems like Apache, everything, and then make the whole kernel patches, attach the kernel updates, and then update the whole system, and then start the stopped application processes, and then check and verify whole application is running or not. But nowadays, with the advent of cloud resources, you don't really need to worry about patching a system, maintaining a system. You just take the latest copy, latest what do you call this machine image, okay, of your operating system with all the patches given by the distributor. Like so, when say distributor, it means just the distribution which is responsible to provide this operating system. It will actually patch them and it will release a new image. Use the image, rebuild whole server, and deploy and delete the whole servers. That is more easier because you have very less impact on your direct end customer who is actually accessing resources via your production system. You're just changing the whole system at all, but your data would be the same. Your RDS would be maintained by Amazon, or your what do you call this? Your database would be maintained by Azure. So you don't really need to take care about updating the software systems of, Amazon and Azure. Your whole and sole requirement here would become is to develop a script on Terraform, okay, to create all these infrastructures, okay, from your pipeline. This is going to be your main focus. That is what current DevOps people are focused as well. And as part of the job, you need to learn how to work with the Terraform, because Terraform is one of the prominent tool which is very specific to cloud environments. It is with the help of Terraform, you can utilize the same code base with multiple cloud providers. Okay, so let's start with Terraform. So we know what is Terraform. We know why Terraform, why we need to use Terraform till now. Now it is a requirement for us to understand what is this Terraform does. Terraforms enable the whole infrastructure, okay, as a code. That means you're gonna write a script or a small snippets of which creates this infrastructure. Okay. So we have something called execution plans, resource graphs. So execution is plan is nothing but once you create the whole your infrastructure, you can generate an object called plan and you can run the plan. It's like end product, okay, where which actually has all the required information, and you can directly run this instead of sharing all the code to your operator. So let me just tell you what happens. Now, if you are an operator, okay, you will have a lot of hierarchy. Now you are the person who is responsible to develop all this infrastructure as a code. You built it, you tested it, you thought this is perfect, and but you have to deploy this in a certain time and interval. Unfortunately, you're not going to attend your job and you have other tasks as well. So you can generate a small plan called Terraform plan, name it, create that object, and let your junior handle that for you, because he has nothing to do other than run the script. So finest execution plan will actually help Terraform to execute whatever that is actually designed in the code base. And you design whole infrastructure in a code format. Okay, and Terraform resource graph. Okay, it builds a complete resource graph to give a visual interpretation of, okay, how this build is going on in your end environment. So imagine this is not, see, we have to understand that every infrastructure at every project is not the same. If there is a small project, then the resource graph has no value. But if you have a very big project which has almost, let's say, 11 to 12 accounts, and each account is nothing but a department, intern a department, you have again very few development team, operational teams. So let's take a very good example of Facebook. So Facebook has so many departments. A department for a messenger, a department for a main app, a department for a particular activity, group activity, and like in parallel, okay, there are a lot more releases will be coming to Facebook. A lot more change requests, a lot more code changes will be pushing to the master branch. In such case, it is advisable, or it is really required to understand our resource graph. That is nothing but a graph which actually represents your resources and your creation of the same, and how you actually modifying or deleting the same. Okay. Now we have something called change automation. So if you are actually changing a lot of components inside your infrastructure, Terraform enables you, or benefits you greatly, because we can actually delete the previous stack and run a new stack okay, in the update. So these are the main few features of the Terraform. The first feature is nothing but infrastructure as a code. The second feature, execution of plans. The third one, resource graphs. And the fourth one is change automation. So I hope you understand what is execution plan. It's an object which is basically enables Terraform to create the whole code based changes. So I'm going to show you the example of the same. Don't worry. Now we have something called resource graph is basically used for visual representation of what exactly happening in a complex infrastructure. This cannot be in the scope, unfortunately, because what we are dealing with is small applications, and you're not gonna really get it because there is nothing much to discuss there. But change automation is something that we're gonna work on. Obviously, change automation means you actually change the complete software stack. But how are you gonna change them? We're gonna see in the code base what exactly we do, and that's what is meant by a change automation. So these are the main features of Terraform, and yeah, this is all about it. So let's actually dig deeper and start installing Terraform. Okay. So how are you gonna install Terraform? Don't worry, you can check these videos if you want. These are very short videos. So this is your installation setup. How are you gonna install? So I'm gonna install this on a Linux platform. So first you need to do is to download Terraform. So where is the Terraform package? So now you have a packages here. You have to choose the best package, that is 64-bit for me. So I'm gonna copy link address and I'm gonna simply get and take the package and type enter. So the Terraform package is here, but I didn't install Untitled, so I have to install it. Untitled. No, I'm Untitled. If you check, there is an executable. It's not directory, it's a file. Now, what I have to do with this file? Just move, check your documentation. Simple. Move this particular Terraform to this file. This is the path. So what I'm going to do, I'm saying, hey, move the Terraform file to this path. Okay, but you need to be a sudo to do that. Now, if you check Terraform, you're gonna get it. So 12.28. So you can check that Terraform is still in 0th version. So it is still in its early stages. So it has been started from 0.1, I think past few years, almost 3 to 4. Now it is at 0.12, but it's not stable yet. It's a cutting edge technology. So that's good. Now, what we're going to do, okay, is to simple. We're going to work with a Docker. So do we have Docker? We don't have a Docker. So let's install Docker. Now let's test the Docker. Okay, so it's working. So let me add this to the group. Razia. Razia. Class बोलते हैं. Okay. Now let's exit. Docker please. Okay, so Docker is working now. Okay, now Terraform is working. Now we got enough. Now let's make the directory where you don't develop Terraform code basics or remove basics. Let's give it the proper name. Automation. Change directory to automation. And here there is nothing. Okay, I hope it is clear. Let's say TR. There's nothing. Zero. Now what I'm going to do, okay, so I'm going to show you very small component. Okay, the first and foremost component of Terraform. So in Terraform there are, see, Terraform has a lot of objects. Okay, so we're going to discuss an object sequence of objects. So the first type is resource object. What is a resource? See, a resource means that this object clearly tells that what exactly are you building. I'm building a resource. So I'm going to copy this particular object. Then let's name, so okay. So what is the file name I have to do? This is for let's give a name demo. Okay, so I'm going to provide a demo, but what I am, see, there are only 3 different types of files in Terraform. Okay, so the first file would be main.tf. Okay, but you need to understand what exactly you are going to create, the name of the app. So first let me create main.tf. Then inside I'm going to paste this one, and here this is a Docker image. So you check. So these are all basic resources or list of providers. Now what is a provider? Let's discuss. A provider is somebody who is actually has an integration with Terraform. If you want to check, you have AWS provider and you have Azure as well. Okay, so all these are all providers. Providers are responsible to create or to provide integration and required API. What do you call this? Required integration with Terraform to create or to build the whole infrastructure. So Terraform has already integrated with all the cloud infrastructures. It has all the required integration in the backend. Now you just need to understand Terraform to provide this build. Now that is what basically a provider means. So there are a lot more providers other than just these 5 top cloud providers, and you can see the provider has these many integrations. Terraform has these many integrations. Now let's go to the page. Where is it? Now I'm going to create a resource, and the resource name is nginx. Okay, so but the name of the resource that I want to go with is not nginx but nginx demo. And if you check, you say name is equal to nginx latest and false. So when I use docker underscore image, okay, why did I write here? You will understand. So I used docker underscore image. I'm saving it. Now what you need to do is you need to use a form called Terraform. Okay, when I use init, it means, hey, Terraform, try to install whatever the required libraries or integrations that I need, or okay, to run this particular main.tf. Because inside tf, whatever I have written is actually provided by Docker provider. So inside the Docker provider, okay, I can write this. The Docker provider has to be local. It's my wish. I can write it. I don't need to write it. Okay, but you need to understand, when I do this, automatically the provider will look for Docker plugin, installs the Docker library required for the providing the infrastructure, and it is successfully initialized. Okay, that means now Terraform has enough ability, required files to run the Docker which is installed locally on this system. Okay, the same goes with if you're actually going to utilize AWS provider. Let me just say, if you are using AWS provider, then if you use this resource type, resource AWS underscore VPC, at that time it's not going to work if you don't do the reinitialization. Okay, you have to always do when you actually increase with a new provider. Okay, so I hope this is clear. If you have any doubts till this point, you definitely have to solve them now. Guys, you have 2 minutes. No doubts? Amaya, Rohit, and Richa?
No, we are good.
Very nice. Now, let's go to our Terraform process. Okay, we have something called main.tf. Now, what is Terraform validate? This is the first step you need to do. You don't really need to write anything else other than this. When you type Terraform validate, it's gonna take up this main.tf and check for any configuration issues. Okay, so now this has been checked and it said that there is no validation errors. Now there is no validation error. It means that now I can run this particular script. So I'm gonna say, so let me show you what happens in Docker first of all. Docker PS, there is no image. I mean, not currently running container, and Docker image, there is only hello world. Even that too, I can delete it now. Okay, it says that I can only remove this post. Okay, Docker images. No images, no containers. Let me remove this one. Okay. Now run. So your stack is clear. Okay. Now you want to run this Terraform. Okay. So apply an F. Just Terraform apply an F main that here. When I say apply main that here, sorry. Wait a second. Okay. What did I do? Maybe I'm getting something interesting. Apply. That's it you need to do. Okay. And now when you say apply, it means what exactly is happening is that so it's going to show you a small demo. That means it's going to ask you, hey, what we are going to do? We are going to create. Okay. We are going to create what? The following actions. The first one, I'm going to create a resource called Docker image with the name as Nginx demo, and it will generate an ID because this is done by Terraform, and it is going to keep locally false statement, and it is going to be the latest and image. The tag is latest, and the name of the container is Nginx colon latest. So what happens? It adds one resource to your current system. You want to perform this, or you don't want to perform this. Let's perform this. If you see now, Docker images, we have Nginx latest. Okay, Nginx latest with image ID. You didn't download it Nginx, right? But this has been downloaded from your Terraform. So you just created this resource. Okay, and it requires 132 MB. Now you want to delete this, you can just need to say, hey, destroy, similar to Vagrant. Okay, when you say destroy, it means that it's going to destroy this, but I don't want to destroy it right now. I want to show you something else. Whenever I create something by using Terraform, this is going to generate something called a state file. The main purpose of this state file is to store the Terraform state. See, Terraform is highly dependent on its state, and you definitely need to maintain this state file. Suppose I lost this state. Okay, now I say Terraform, okay, destroy. What exactly it's saying? It's saying that, hey, Terraform will destroy all your managed resources as shown above. There is no undo, accept. So it is going to delete all the resources. It's not going to show me what is going to delete. It's going to delete everything. Okay. Now, if I say cancel, okay. Now I wanted to update something. I wanted to add one more resource. Okay. So let me get some resource for you. Okay. This is interesting. We have another container called, okay, a Docker container with the name foo. And the image is Docker image underscore ubuntu.latest. So this is the reference. So let's not go into depth. I'm going to describe that later. So I want to add this another resource. Okay. Now I just changed this. Now you see, I lost my what do you call the state file. Now I have to I edited my Terraform file. Now I want to update my infrastructure. Terraform validate will show nothing. Terraform plan. So this is the plan I'm making. Okay, I want to update this. So when I say without state, so Terraform is first what it's trying to do. It is trying to refresh Terraform memory. That is, it is actually looking for the state file. It didn't find anything. So it is not what it basically is doing. It's going to create everything. But we already have this. So imagine yourself, you lost your state file in your cloud infrastructure. Okay, your infrastructure is running. Now you want to update your infrastructure. Now you recreate the whole infrastructure, and your current running infrastructure has no means of handling with Terraform. So that's how critical a particular state file is about. So you always need to maintain your state file and always need to work with one state file if you are working with one infrastructure. If you are using multiple infrastructures, then you can have multiple state files, but each infrastructure on an account would have to maintain Terraform with a state file. I hope this is clear. Now, if you see ls, you'll find something called without state. What is this without state? I just wrote without state, right? It's some gibberish. But what is this gibberish? This is understandable by Terraform. This is a machine language executable file. With this file, okay, with this file, one can actually create the state. Now let me run this. Okay. Now I'm going to say without state. Now I'm actually applying what? I'm not applying main.tf. I'm applying whatever I created in without state. What exactly happening? It is creating a Ubuntu image. It is creating a Nginx demo. Now, again, a new state file is created. Now, if you check Docker images, there are two files, or two images. One is Nginx, one is Ubuntu. So, if I have this particular without state plan, I can actually run number of times. Okay. So if I maintain my TF state and without state, then it's easy for me to make sure that this code is maintained at repo level and everything else is maintained at pipeline level. Now, let's say, so you already know the main two things. The first thing is how you actually maintain your Terraform plan, and what is the main importance of your TF state file and the necessity to maintain it in a clean manner. And you also know about feature about a plan, which is basically a Terraform feature of executing the whole infrastructure. Okay, now you're done with the three. Now it's time for us to actually look into a bit more depth towards how you gonna reference, how you gonna variabilize your code base. Now you're clear that okay, if I actually go to this main.tf, we can clear that hey, I can mention a lot of resources here. Currently these are Docker images, but if I want to work with, I can change the image, I can change the resource type. Okay, now that's good. Now imagine an infrastructure which has a bit of complexity involved. So in real time, if you think about, you also require to have a multiple images maintained, multiple deployments maintained, and multiple what do you call this infrastructures to be built. It's not just about a single image. Now, in such cases, you have to variabilize. Now, if you take the example, okay, so let me take this resource. Sorry. Okay. Now, I wanted to run an image. Okay, this is the image I want to run, but I don't want to hard code like this. This is called hard code. I don't want to hard code this, but I want it to run with a reference. So this is a variabilization. Okay, so now if you check, the image is referenced. So when you say dollar brackets, and whenever you mention Docker image, you are mentioning this image, I mean this resource type. So the resource type, resource name, and inside the resource, this is the main variable. So inside the main resource type, resource name, and once you give this Ubuntu latest, okay, which is basically this particular reference. Okay, now let's run this Terraform. When you don't want to create but you want to dry run, you can always run Terraform Plan. So whenever you run Terraform Plan, it is going to show you if there are any warnings, or it is going to show you what is going to happen, what is going to get created, and you can verify. But this is going to be long list if you are working with a complex infrastructure. So you have to use it, but you have to you should not you should more totally avoid time investing as well. So it's up to your call how you want to work with. So let me just wanna go with the main here. This is a bit older, so all you need to do now is to just directly mention, okay, if you just directly mention docker image dot ubuntu dot latest, okay, that should be. You see, there is no warning message. But before there is a warning message. This is due to latest Terraform upgrade. So you have to be cautious with the Terraform is that Terraform has a lot of breaks when it actually updates its minor versions. So tweaks are fine, but when you have a version upgrade from, let's say, 0.12, 0.11 to 0.12, a lot of features have been changed. Even the syntax of the lot of stack is changed. So you always need to be careful. Now, I'm going to run this. First of all, I'm going to create another plan, second plan. Okay. So I just created a second plan. Now I can actually run this second plan. So how do you apply? Apply. What do you want to apply? This plan. You see, since I already maintaining this TF state, okay, now I don't really need to create again all three resources. Only one change I implemented, which is actually implemented here. So since it's already have Ubuntu latest, let's use that. So this is in short regarding Terraform utilization. Okay, but tomorrow we're gonna work with an example. We're gonna look into all the Terraform variables and how you're gonna reference. So we're gonna work in a structured manner, and by end of tomorrow we will be able to complete Terraform. Okay, so this is gonna be a short class on Terraform, but this would be sufficient for your interviews at least. And if you can practice a bit, this will really help you a lot. Okay, I hope this is clear. Any doubts so far, guys?
No doubts.
Okay, I take it as a no doubts. Then let's meet tomorrow and let's work on a complete code base. Bye bye.